Alright guys, welcome back. In today's video we're going to solve another question from chapter 4 of Beer and Johnston textbook, and we have this beam that we know the maximum value for each of the reactions at point A and B is 180 Newton, and we need to neglect the weight of the beam, and the question is asking to determine the range of the distance for D over here. So as always, we're going to start with the free body diagram. At point A, we have a roller, which means we have a normal force A. And at point B, we have a pin, which means we have both X and Y component. Looking at the free body diagram, since we are in equilibrium, there is no force in X direction other than Bx. And for our equilibrium, we have sum of all forces equals 0, and same for the moment. From here, since sum of all forces in X equals 0, we only have Bx. That means our Bx is 0. And so we have one Fy equation, and we could use our moment equations. But since going with Y, we still have two unknowns, it makes sense to go with our moment equation. Let's start with the moment about point A. Counterclockwise positive as always, and let's see what we have. So we have this distance here, D, and we have these two 450 millimeter in the figure, which means this distance will be, if we want to write it down based on meter, we need to divide it by 1000, and it will be 0.45 meter. So let's start with the moment of each of these forces about point A. So let's start with the 50 Newton to the very left of the beam, and since it's going to make it counterclockwise, it will be positive moment times D. For the 100 Newton force, we have a clockwise moment, so negative sign, and distance will be what we have in here, which is 0.45 minus D, and the next will be the 150 Newton. Again, we have a clockwise moment, and the distance this time is 0.45 plus 0.45, which is the length of the beam minus D, which would give us this distance. We have the same moment for BY, the same distance for BY. So 0.45 plus 0.45 is 0.9 minus D, which is the same as the 150 Newton force. And this is equal to 0. And let's break it down and see what we can get. So from the first one, we have 50 times D minus 45 plus 100 D minus 150 times, but this will be 0.9. So we have 150 times 0.9, which is minus 135. And we have minus 150 plus 150D, and we have 0.9 by minus byd equals 0. And from here, let's find the ones that have D. And so we have, if we factor D in here, we have 50 plus 100 plus 150 minus by, and the rest will be minus 45 minus 135, which will be minus 180, and we have 0.9 by2 equals 0. And from here we can find D based on by. So if we take these two on the other side of the equation, we'll have plus 180 minus 0.9 by divided by, here we have 300 minus by. So that's one thing that we get from our first equation. And we know we have conditions for A and B. We know that both A and B cannot be more than 180 Newton. So we're going to take advantage of, we're going to apply this condition later, but so far we found by, but we have information about A2. So we're going to do the moment about point B, and that way we're going to find D based on A. And let's see what we have for moment of all of this about point B. So all the three red forces, I mean the 150 won't make any moment about point B. So we have the 50 Newton force counterclockwise moment, 100 Newton force counterclockwise moment, and we have the moment of A. Let's start with the moment of the 50 Newton force. The distance will be the length of the beam, which is 0.9. We have also the moment of the 100 Newton, and the distance will be, since it's in the half of the beam, it will be 0.45. And the last one is A, which is what we're looking for. It will be a clockwise moment, and the distance would be, let's get back to it one more time. So the moment of A from here will be again the distance that we found in here, which was 0.9 minus D. And this will be equal to 0, and we can find our D. So from the first one, we have 45 plus 45 minus 0.9A plus AD. If we want to find D, we simply have, and they will be in a positive sign when they go in the other side, and 45 plus 45 will be negative. And that's the second condition. So we found these two, and what we need to do now is just to use our two value that we have for A and B. Let's start with the first one in here. I'm gonna show it in green. So here in this condition, we know that By cannot be more than 180 Newton. And let's put our 180 in this and see what we get for D. So our D will be 180 minus 0.9 times 180, which is the value of the maximum value that we have for B, divided by 300 minus 180. And if we calculate this, we'll get 0.50 meter. So from this condition, when B is at 180 Newton, that's the distance that we get. Let's put the same thing for A. So this time we're gonna use this equation that we have for A, and so that was from the first equation over here that we put our B 180. Now we're gonna put our A 180 in here. So what we get is 0.9 times 180 minus 90 divided by 180. And if we calculate this, we'll get 0.4 meter, and that shows the range that we can have for D. It can be minimum 0.50 meter, and the maximum will be 0.4 meter. And that would be the final answer for this question. Thanks for watching. You guys take care. I'll see you in the next video.